Let's solve 2024 IMO problem 5. Turbo the snail is in the top row of a grid with 2024 rows and 2023 columns and wants to get to the bottom row. However, there are 2022 hidden monsters, one in every row except the first and last, with no two monsters in the same column. Turbo makes a series of attempts to go from the first row to the last row. On each attempt, he chooses to start on any cell in the first row, then repeatedly moves to an orthogonal neighbor. He is allowed to return to a previously visited cell. If Turbo reaches a cell with a monster, his attempt ends and he is transported back to the first row to start a new attempt. The monsters do not move between attempts, and Turbo remembers whether or not each cell he has visited contains a monster. If he reaches any cell in the last row, his attempt ends and Turbo wins. Find the smallest integer n such that Turbo has a strategy which guarantees being able to reach the bottom row in at most n attempts, regardless of how the monsters are placed. So the answer is actually n equals 3. And that seems quite small, surprisingly. So now let's prove that n equals 2 or n equals 1, those are not possible. So let's just say Turbo gets unlucky, and when he moves into the second row, here, let's just say he moves in here. And so there's nothing Turbo can do about it, but there might be a monster there. So there might be a monster here, and so then that's one attempt. And then on his second attempt, he's going to go in to the second row on a different column, let's just say this column. And then here now he can go into a cell in the third row that's not this cell, because he can't get to this cell. So let's just say he gets in here, this cell. And there might be a monster here. There's nothing Turbo can do about this. And so therefore, he must take at least 3 attempts. And now we'll show the strategy that, in which Turbo wins with exactly 3 attempts, or 2. So so the first attempt, what Turbo is going to want to do is try to locate the first monster in the second row. And so it doesn't matter where it is. So let's just say it doesn't matter. So let's just say it's this one there. So that's monster. That's the first monster. And so now Turbo has 2 attempts remaining. And so now there's 2 cases about where that monster is. Either it's on one of the 2 edges, or it's on one of the 2021 non-edges. And so the case when it's not on an edge is actually easier. So we'll do that one. So let's consider these 2 paths. And we know they exist inside the grid because it's not on the edge. And these extend all the way to the bottom. And so let's start by Turbo taking the first of those paths, starting from here and going down here. So Turbo will know that there's no monster in the first row, so Turbo will be safe there. There's no monster here because there's a monster in that green spot. There could be a monster there. So if there is a monster there, so there's 2 cases. There's a monster in that third spot, or there's not. If there's not, then Turbo can go here and then go down without worry, because there's only one monster in every column. So let's assume there is a monster in that spot. So in that case, Turbo will take the other path. So he'll go there, which is safe. Here is safe. Here is safe because we know that this one has a monster. And then he can continue and finish. So that's the case when the first monster is not on an edge. Now we'll handle the case where it is on an edge, which is a little harder. So that's the starting row. And so it doesn't matter which edge it's on, but we'll just say that it's on this edge. It does not matter. So now for Turbo's second attempt, we'll have him go in this path all the way down to the bottom. So if this path works and there's no monsters in any of these cells, then we're done because there's no monsters. So that's good. But if there is a monster, then let's just assume. So let's just say that there's, like, for example, there's a monster here. But it could be anywhere on this path. So what Turbo will do, now I'll use a different color, maybe blue. So he'll go along this path for this case. So he'll continue along this path until he reaches this, like, where he's going to hit that monster. So if he goes right here, then he'll hit that monster. So instead, he'll go down because he knows that there's a monster here. So so there's not going to be any other monsters in that row. So he'll do this. And so that's just not just true for this case. If there's a monster here, then what he can do is this. Follow this path, and here we can go here. Wait, no. No, that does not work. You have to do this. Because if you did that old path, then there might be a monster here or here. Okay. So what if the monster is somewhere like here? Then you can do basically the same thing. You continue along that path, but if we go this way, then we'll hit the monster. So I'll go this way instead. And this will work. And so this always works in 3 attempts. So that finishes the problem. If you like this video, please like and subscribe. Thank you.